everyone, my name is Aniket Kasturi and I'm a student of M.Sc Cybersecurity studying in National College of Finland. Today I would like to demonstrate my thesis project, which is named as FAST. Let's dive into it. So FAST, why? It's an abbreviation for like fortifying API security testing, a framework for automated API security testing. Let's start with the introduction and what it is. I will run through it. Before starting with that, here's an outline of my PPT, like how the show flow is. Starting with the introduction, moving on with the research question, followed by the methodology, and in the end with the evaluation, along with the outcomes and conclusion and future work is the outline of the presentation. Starting with the introduction. As we all know, in the world of web applications and in the world of digital era, we have a lot of web applications hosted in the internet. And a major concern is like every tech stack is now moving from monolithic architecture to microservices, and if there are microservices, there are a lot of API suites to be developed separately. So why not to protect that? And for protecting and security testing of those APIs, we need manual penetration testers who perform few security test cases, check to find flaws and the vulnerabilities in that, but that often consumes a lot of time to find the same. My study unveils an innovative approach to automate security testing for APIs, like with the objective of accelerating the identification of vulnerabilities. My project majorly focus on like developing custom script, which is cost effective as well, and without taking any premium software for the automation security. We can automate the process of few test cases, which will not only help the manual testers to invest their time in a bigger vulnerabilities rather than to do a few of the repetitive test cases, which is done like in every production release or prod release whenever it is. What is my research question? My research question is initially the main highlight of is like how can custom scripting be leveraged as an automated tool for driving API security pen testing with a focus on creating custom security test cases. And I will also highlight the benefits and the limitations of using automation scripts for conducting API security pen testing compared to the traditional manual testing methods. Moving on with my methodology, I have given in the phases, like first phase is to deal with the identification of what kind of vulnerabilities I will be implementing in my automation security framework. So I have taken few of the top 10 list of the OWASPs. You can take anything from like SANS 25 or something, but I have used like few broken object level authorization, broken access control, insecure direct object references, along with SQL injection. These are the few of the test cases which I will be automating in my framework. In the next phase, there is a documentation of API. First, you need to find a target. In my case, I have used the target as this RESTful Booker API Heroku.com. It's a vulnerable website you can use for like testing and other purposes. You can see this is the website of that. Once you go to the documentation, you can find the how to create the token and the username and password and few of the APIs which I mentioned over here. Moving on further, like I've also created an environment configuration file which is in my implementation software, that is Postman in my case. And main purpose of is that like whenever there is a response is being generated having few of the data, I am saving that data into the environment file rather than saving in any of the scripts. What I have done is I have developed few of the custom test cases for the vulnerabilities which I just mentioned, which are inclined to the OWASP top 10. And after that, evaluation and testing is done in the software of Postman, having the runner tab collection results in which we can find the vulnerability detection is being found or not. Implementation. Coming on to here, as I mentioned, I'm using Postman Community Edition, which is free of cost. And yes, we do have an option to automate few of the API test cases in the premium version of the Postman. But yes, of course, that is not pocket friendly, and many of the organization won't invest that kind of money to just have few of the test cases being run on their organization. So my thesis or my project is cost friendly as well. To improve the effectiveness, I have also developed few of the vulnerabilities test cases for them. As earlier mentioned in the OWASP top 10, here are they: broken access with mass assignment, IDOR, input validation, broken object level authorization, and few of the security headers, which needs to have in the API. What does this is like? The impact of this project will be measured by the capabilities of time efficiency, attack vectors, attack time consumed by the automation software and manual testers. This is the case in my implementation. Vulnerabilities identified, I have already mentioned, will come under the failed test cases of the Postman software. I will be giving a demonstration of the same in just a minute. Reliability, yes, of course, Postman has the dynamic functions of using my environment file so that we can fetch the data from that file, use it in the APIs, endpoints, URL parameters, however we want. Performance impact, yes, of course, if there are number of endpoints will increase, resource utilization will increase, depending upon the number of API you have in your organization. Scalable, yes, of course, Postman is very much scalable. You can integrate this with the GitHub CI/CD pipeline. Along with, this is very helpful in future work, like whenever there is a production release being posted in the new beta release or new any kind of things, the security test cases will automatically run and give any of the results which if there are vulnerabilities or detected or not. Let's dive into the implementation of this. As you can see, I have used my collection. This is my collection having a few of the APIs from that testful booker. I have written few of the test cases for to check for PII data, which is personal identifiable data, which will have these kind of values to check if there are any kind of responses present or not. And it will flag it if there is responses related to these data have been found. Same goes for if to check whether there is strict transport security is there or not. Same with CSP, X content type, frame options, XSS protection header, content cache control, permission, and rest of the security headers, which is necessary in the APIs. Starting with this is just a simple plain login call as we've seen in the RESTful booker. Here's the admin as the password. Let's start with the checking how I have written the scripts to automate few of the test cases. Create booking. Yes, of course, this will create a new booking. So let's check. Is this the same call? Let's check for a mass assignment vulnerability and how I have proceeded in this. As you can see in the script section, I have written prerequisite script should. There is a body having a value of this admin set to be true, but a user cannot change this value. So why not to change it? And let's see what the response will be. The results will be shown at the end when I run the Postman collection tab runner. So here I'm in the prerequisite, I'm changing this to isAdmin setting to be false and observing what kind of responses it shall have. In the post response, this is the ideal observation that will flag my cases. This was for the mass assignment. With broken, I have mentioned here with broken access control, because let's test this with the basic auth username password. If there is no password, whether we are able to log into that system or perform this particular call or not, that we will check in the Postman runner tab. Moving on to the SQL injection. Let's check what here is. Like in the body, there's nothing. It's a simple get request. I am just having few details of booking ID 1, and in the pre-request, I'm changing it to why not to change with the SQLi injection payload. I will replacing /1 this endpoint with the generic SQL payload, and will be observing what kind of results I might be having in the same. This is the script which I've written, and I'm also checking for the responses, like ensure no injections. This is just a string, and if any of the error codes are invisible, it will flag for the same. Here it is an input validation system. As in the body, you can see first name is James, last name Smith. It's like they both are inside a string. Yes, of course, last name, we have the basic logic is like it should be a name. But why not to check for any other input validation systems? So what I'm doing here is in the prerequisite, I am using the body last name and changing it to an integer, whether it will accept it or not, or else it will throw a flag of error or not. These kind of tests which can perform for the input validation. And in the post response, we will get like check for validation within an if else condition. If there was an error, it will say invalid or not. Moving on further with the insecure direct object references, here it is like whether we can check if I am able to watch any other booking ID's data or not. So what I'm doing here is I will be changing this input request parameter and will be observing if I am able to change or get any of the details of any other user. Like booking ID here it is 2, initially it was 1. If I get a positive result, then I will be definitely saying that ensuring that user cannot access other users data. Moving with this was clubbed with the broken object level authorization, as it is the same clone request of this one. It was found that this object ID here in case booking ID was vulnerable to broken object level authorization as well. Instead of giving ID, we can give any kind of gibberish, and without any authorization or any kind of validation, it just was able to give the results for the same. Yes, of course, this is vulnerable API, hence that's the reason we are getting few of the vulnerabilities. Let's start with like how to run each and every run our automation security on this. These are the API cases. I'll clear the console. If I cross this, if I run a new collection, I will persist the responses to check in the console just in cases of you logging. And I will run the API security automation. This is the collection name. All of the API will be tested for each and every security test cases which I have written in this collection. That was it. Everything was done. And if you can see, let's check for mass assignment vulnerability. It is showing as checks for PII passed. That means there were no PII to be found. Security headers, few were failed, just one was passed. I can show you this. Like if you click on this, headers, we found a content type. Yeah, that was passed. We don't have any X-frame protection content type strict transport security in this. That's why it is showing as failed test cases. That means this is vulnerable to of this is. Yes, of course, ensure is admin property is not updated, and in our case it was updated. As you can see, the response body, request which went here, initially it was set to true, but in the prerequisite script we wrote a script to change it, and it was, I think, this one. Request body, yeah, here it is admin was set to false, and hence we still got a result of 200 okay, and it was flagged that mass assignment vulnerability was found. No sensitive data was exposed, good thing. Moving on with the SQL injection thing, did we find any? Same security headers check, ensure no SQL injection succeeded, it failed. Let's check why. Here was the modify URL. Yeah, here was the the generic payload which we got or not. As you can see, this was the request of SQLi. Few of the special characters got URL encoded, and we saw that response body here. As you can see, there was a successful request of 200. This means SQL injection was identified despite of URL having the sanitization or not. We got details of the same. We got details inspecting while giving the SQLi injection payload. Here is the response details, as you can see in this one. Moving on with the input validation. Let's check for validation on the last name. It failed. What does the console has to say about it? That means it accepted request body. If we inspect it, oh, see, despite of having this, it accepted the input validation. So we can say that input validation was found over here. Insecure direct object references, no user. We got a response of 200 okay. Let's check the yeah, despite of changing it, we are able to get the response of other users. As you can see, first name Susan, last name Smith. If I have to show this to you in the manual terms, it will be like earlier it was 2, I am running it as 1 or like something else, a different ID. If I clear the console, send it again, see, earlier it was Susan, now we are getting Mark and Wilson's data, which is having a booking ID of 1. This shouldn't be visible to anyone. Like, why would some user would be able to see any user's data, his details, like what the booking date was, deposit paid or not, what the price was. This is how we identified the IDOL vulnerability in that. Same moving on with the broken object level authorization. Failed because no object level was accessed, and as I mentioned in this API call, this parameter, this object was vulnerable because RESTful Booker Heroku app is vulnerable to that. So I have used this one to show you and demonstrate how this kind of vulnerabilities can be encountered, and this is the type of results the postman gives you to check whether to get the security issues found or not. If just in case, if this all the cases I have to consider and give a time to manual pen tester, like how he would have used to do, then there is a significant difference in the time efficiency like the software can do and the manual testers can be able to perform. Main concern of this thesis is like to save time and to invest more, to give the time of security headers to focus on major vulnerable security issues rather than doing few of the repetitive test cases. Moving on with my PPT, that was the implementation which I showed you just now. Moving on further, evaluation. As of course I said to you, time efficiency is a major constraint. Manual form of testing requires a lot of time for the inspecting requests and responses across different endpoints. As you can see, time efficiency for manual testing was like for one endpoint and performing the security test cases of my postman, the few IDOR, POLA, SQL injection, and broken access control and input validation took manual tester. In my case here, I was the manual tester, so it took me like 5.38 minutes, and for the automation it just took 0.016 seconds. There's a huge difference. As you can see, it is linearly increasing. For the 4, it took me 30 minutes. For 7 endpoints, it took me 45 minutes. For the same automation software, it took like 0.03. The same manual effort done on a software, automated software, can save a lot of time, not only in the organizational structure, but also to give manual testers a lot of time to focus on the major challenging security issues. Attack, this is a graph also for attack time consumed. As you can see, for the manual one, security headers is in blue. It almost took like 1.5 minutes to check for each endpoint. And as you can see, it's less than 0.5, or I can say less than half of the value of the 0.5 in the automation one. Everything which you can see in the automation is less than 0.5 or something. And instead of that, as compared to the manual one, you can see we have consumed a lot of time for each and every attack of mass assignment, POLA, input validation, and broken access control, which I have used in my implementation. Another part of evaluation is cost implications. Yes, of course, there is modifications and premium software available in the Postman, the Enterprise Edition, which helps us to get the automation done by easy steps, but those are not pocket friendly, and or in my thesis is also focusing on cost effectiveness. So just by writing few scripts, devising it with the architecture of the API suites, we can perform the security test cases without giving any additional extra cost to the premium softwares. There will be hardly any CPU and memory differences if there are less number of endpoints. Yes, of course, this resource utilization will increase if there is like more number of bunch of API suites or something, which in real life data organizations do have. What is the outcome of this research? My major outcome of this research is it demonstrates the effectiveness of implementing like how a automated API security testing frameworks tackles my research questions of custom scripting and saving time as well, and what was the benefits and limitations for the same. As we said, automation via custom scripting was done in Postman software, which helped to get me an automated test tab collection result, which is also very user friendly to see, to flag the vulnerabilities, and to save a lot of time. This direct implementation corresponds to my objectives of the research and illustrates like how my automation facilitates the process of vulnerability detection, which is less resource intensive and very hardly any prone to human errors because it's a machine and a script written by a developer or now. Majorly, my solution was also to drag down the time from manual testing. Like I was able to manage to get down from 30 to 45 minutes on a few 5 to 7 endpoints to bring it under like 5 minutes. That was thus improving the productivity and saving a lot of time for for the security testing of APIs. Yeah, moving on with the future work. What else can we do in the future work? It's like, yes, of course, this Postman is very much flexible. So what you can do is you can take continuous security testing to CI/CD pipelines. Whenever there is an organization releasing their production push or something, there is a security test case, security testing being done. So rather, whenever there is a GitHub push being done, you can implement these kind of CI/CD pipelines, which will have scripts written in this. This will automatically check for any of these few repetitive test cases, and which will save the time of manual testers to focus on the different aspects of the higher vulnerabilities rather than investing time in the repetitive test cases. Also, we can do is like we can integrate perp suite with this along in the future work to give an advanced vulnerability detection, which will precisely give higher vulnerability detection chances. Also, we can do is like we can implement machine learning algorithms to not only filter the traffic but also flag the malicious ones. As rightly said by Mr. Jim, effective cybersecurity is not a product but a process. That was the future work of my thesis, and that was the thesis which I have made. Thank you so much for your time. Thank you.